What's this business about internal energy? The energy that's inside something? Let's find out. Roll that graphic. Hi, I'm Paul. This is Science That Sticks. And in this session, I'm going to be looking at internal energy. So what is this business of internal energy? Well, the definition of internal energy is it's the total kinetic energy of the particles in a system, along with the potential chemical energy. So what does that mean? Let's consider water for a moment. Each of these lines represents a covalent bond. Now, if you've been watching my videos for a while, you know the covalent bond has two electrons that are sharing it. It requires energy to break them. It requires energy to form them. Now, if we look at ice, the water molecules have these forces in between them. They're not bonds, they're forces of attraction. We call these intermolecular forces. Now, in ice, there's quite a lot of intermolecular forces, and the structure's quite uniform, very much like you would see in a solid particle diagram. Everything's in the right place and so on. Now, here's the thing. When you start to heat ice, some of these intermolecular forces start to break. And as they start to break, the particles, whilst they can move more, they actually are able to vibrate a lot more. Now, what's this about internal energy? Well, remember the first part of this is the kinetic energy of the particles. Unless you're at absolute zero, which is negative 273 degrees Celsius, all particles are moving, whether they're in bonds or not. Now, this is quite an interesting thing, because with ice, although it is freezing, it's not absolutely freezing. And so what's happening is that as the ice warms up, the intermolecular forces start to break. The particles, although they were moving anyway as part of kinetic particle movement, they're able to move a lot more. This means their internal energy increases, and you can see that in this little time lapse. Now that you've seen that, if we were to extend this to putting that water into a kettle and watching it boil, we're not going to do that. A lot more of these intermolecular forces will actually start to break as well. The particles are able to move a lot more. And because they're a lot more freer, they move with more kinetic energy, so therefore the internal energy increases. So what's this got to do with chemistry? Nothing to do with chemistry, but everything to do with physics, because internal energy is one of the many things that students have to learn about for GCSE AQA physics. Now, it doesn't matter whether you're foundation, doesn't matter whether you're high, it doesn't matter if you triple, doesn't matter if you combine. You still have to know and learn these things. It's not that difficult. It's barely even an inconvenience. It's really simple to answer these questions. You put something hot in the water, what happens to the internal energy of what was hot? It decreases. What happens to the internal energy of the water? The water gets hot, therefore the particles move more, so the internal energy of the water increases. That's it. That's all there is to it. Stay cool. Bye for now.